I'm Matt Muddyman with the pressure sensor team, and I'll be introducing today the NTM88 family of tire pressure monitor sensors. We'll be introducing today the NTM88 family of light and medium duty tire pressure monitor sensors. We have a short agenda with a product summary, talk about target applications. We have a few market challenges, and we'll offer some solutions and our advantages, and then we'll wrap up with support, collateral, and ecosystem. So a quick product summary. The NTM88 family of tire pressure monitor sensors, abbreviated as TPMS in the industry, is a fully integrated 4x4 by 1.98 millimeter package, which is about 67% smaller than our previous generation, which had been on 7x7 millimeter package. It also provides low transmit power consumption, large memory for customers, and a specific dual-axis XZ accelerometer architecture. The TPMS solution integrates an 8-bit CPU, pressure sensor, as mentioned, the accelerometer, a voltage sensor, a temperature sensor, an LF receiver, and an RF transmitter all in one package. The part numbering scheme includes a couple of suffixes to help customers understand which part they're buying. So the H suffix denotes the pressure measurement range of 90 to 930 kPa, typical for light-duty passenger vehicles. The J suffix would denote the pressure measurement range 90 to 1110, typical for medium-duty delivery vehicles, small buses, RVs, things of that nature. So the TPMS support the NXP themes of sensing the pressure changes, enablement of thinking and acting via the customer algorithms running on the embedded CPU, and finally connecting via wireless links to the vehicle. So here we have a page that provides some of the details. On the right, we have a block diagram. So as mentioned before, there's the core, the SO8 8-bit core. In the middle of the system support and the memories. And then we have the radio, the transmit radio, sub-gigahertz transmitter. Then there are some supporting blocks, analog section with an 8-bit, a 6-channel 10-bit ADC, and then some custom circuitry called sensor measurement interface. This is to allow the circuitry to connect to the pressure sensor, the accelerometer, and the temperature measurement portions. Then we have standard timers so that customers can schedule events, a few external interfaces in the case that the sensor might be connected to other peripherals, and then a standard set of clocks and internal timers. The pressure transducer itself is based on what's known as a P-cell technology, and essentially this is the buildup of an electronic diaphragm, so that as pressure changes, we get a capacitive change in the signal, and that's what we're measuring. It offers a very high robustness against burst, which is an industry problem for pressure sensors in general. And then we have the motion sensor is a dual axis accelerometer. And again, this is based on two matched capacitors, so we're sensing capacitance change again. This is a small package, the 4x4 by 1.98 millimeter footprint. And then lastly, we want to make sure that customers are aware that this is qualified for automotive uses. A word about our target applications. So typically the sensor is located inside of a module, an electronic module, and then the module is installed as part of the tire and wheel assembly. So if you consider a car, there would be 4 tires. Each of the tires would have our sensor in it. And then the software that's running in the sensor would transmit some data to the car over the RF link. So typically there's a unique ID for each of the sensors. There's the pressure measurement, the temperature measurement, and some rotation data based on the accelerometers. And then the car would receive this data from all 4 wheels and send it down 2 paths. One path would be to the driver information center. In the case of, say, low pressure or maybe a high temperature, there might be a telltale that comes on to the driver information display. The same data then might be aggregated with other data from the vehicle, for example, the engine management system where you have engine RPM, oil temperature, coolant temperature, transmission, those types of pieces of data would be combined with the tire data and then sent out of the vehicle over whatever wireless link is available. Most cars today have Wi-Fi, they have telephone on board for safety systems. There's Bluetooth, the connection over to the customer's mobile phone, And then DSRC, acronym for Dedicated Short Range Communication. This would be for communication between car to car. The modules that I spoke about a second ago tend to come in three basic flavors. There's what we call a valve or rim mount. And this is a small electronic module with the sensor on board that is attached to the back side of the valve stem. And so the assembly process is a little bit complicated. The operator has to install the valve stem first and then attach the electronic module with TPMS on board, and then they mount the tire and inflate. So to save the car makers a little bit of money and time, the tire makers have entered into this business as well, where they attach the module to the backside of the tire rubber itself. So this saves the step of installing the module onto the valve stem. And then the trucking industry and the RV industry has adopted even further, where the module attaches to the outside of the valve stem in order to allow the sensor to be removed easily or moved from one vehicle to the next. So the tire pressure monitor sensors used in light and duty medium vehicles. The market basically is driven by government mandates. Two types of mandates exist today. The first is aimed at reducing risk of accident induced by low tire pressure. And the second is a mandate aimed at energy savings, essentially by way of making sure that the tires are properly inflated and therefore the rolling resistance is optimal. So the sensor is available to enable the development of small and light tire pressure modules for wheel assemblies, and also with the low power consumption, extend the battery life. Also enables new software coming from our customers that might develop their own applications. Examples would be an auto learning of the ID, tire contact patch measurement, for example, or the tire inflation assist. Essentially, when you put air into the tire, the car will flash the lights or honk the horn to tell you when there's proper pressure in the tires. So our key customers are going to end up being traditional tier 1 automotive electronics suppliers who serve by selling the OEMs or the tire makers the module that I spoke about a second ago attached to the rim or the valve stem. But then the modules being battery backed, they tend to wear out over some period of time, 6-7 years, for example. So there's a large aftermarket developing where another set of suppliers would serve to replace the modules that have died in the car tires at the moment. So they sell to tire repair shops, dealership, service shops. And then lastly, there's an aftermarket that is developing around do-it-yourself kits for RVs and construction trailers, things of that nature. You would buy a kit that has not only the tire sensors, but also some sort of a receiver that might plug into your cigarette lighter, for example, or to a USB port. So a couple of points on market challenges and the solutions that we offer. So the first and probably the biggest selling point for the part is there's a need for the smallest package size. This is so that the module themselves can have the lowest mass and have the least amount of influence on the rotation of the tire itself. You don't want to have a tire that's out of balance, so therefore you need the smallest mass. So we integrate everything into this small 4x4 package, and this again enables the customers to design the smallest module possible. We integrate the dual axis accelerometer with a number of trim ranges available, and this supports a number of mounting configurations. We'll have a little summary of this at the end. Lastly, the package height we're trying to maintain as a standard. This allows customers to easily transition from the previous generations where they simply change the artwork of the circuit board to accommodate the 4x4 sensor if they had been using the 7x7 in the previous generation. Next is a need for software development flexibility. So we offer a fairly large memory, 16 kbytes. Typically, this is occupied by about 1K of calibrations that come from our factory, and then 15K for customer development routines, special functions. A typical customer that does a very simple implementation would end up using about 5K. So this is a little bit oversized for the applications today. And what we're intending here is that customers would be creative and start to figure out new things they could do with the sensor, taking advantage of the accelerometer, the temperature and pressure, and combining these things in some fashion. We offer a fair amount of software free of charge under a license agreement. For example, an over-the-air reflashing of the memory with called a bootloader. We have an application that is an angle calculation for the transmit, and this allows the sensor to transmit the data at a precise wheel rotation angle, and then the car is enabled to figure out which tire is at which location by knowing when that message came in. The wheel direction and the period are calculated from the accelerometers, so whether the wheel is rotating clockwise or counterclockwise, and then how fast. And again, this is another indication of whether the pressure and the temperature and the load of the vehicle are optimal for the vehicle speed, making sure that the wheel is not overloaded. We offer a number of configurable measurement libraries in the case that the customers might want to change the sampling rate or some filter characteristics, things of that nature. These are all posted on our nxp.com website for easy download. And the last is the need for efficiency, and we've mentioned already that we have a very low power consumption during the RF, and that leads to the longest battery life. So to point a few of these out on a block diagram, these are some of the highlights. So again, to reiterate, we have the CPU based so that customers can create their own unique and differentiated solutions. We have sufficient memories to support that. We have the integrated RF transmitter, and we have the integrated transducers and the interfaces for those as well, sensing pressure, temperature, motion, and voltage of the battery. And then lastly, there's a low frequency 125 kilohertz receiver that supports the over-the-air reflashing. So next point is on the support collateral and the ecosystem. So we provide an evaluation board. This is a small board about 25 centimeters or 1 inch in each direction. So here we see the NTM88 sensor in the center. Has a number of passive components for filtering of the battery. For example, there's a crystal so that the clock for the CPU can run, and then the crystal is also used to generate the carrier for the RF transmitter. Sorry. The RF antenna is here across the bottom, and then I mentioned a second ago the LF antenna is across the top. So again, everything is very small, compact, and flexible for the customer. So this evaluation board is available by contacting our representatives at the division, and customers can typically have 3 or 4 of these things in order to start their software development, and then they would replace these with their own designs that would be customized for their application. So to summarize some of the information that can be downloaded from the web, we provide the Gerber file for the evaluation board that we just showed a second ago, the electrical schematic. There's also the CodeWarrior software integrated developer environment that's downloadable. We offer some software applications that have been developed for customers, again, to manage the LF and RF bootloader application. And then we have this is an example of one, but we have a number of angle calculation algorithms so that customers can quickly develop the auto localization routine that we talked about a second ago. A little more detail behind the part numbers. We have a number of parts that are readily available now. Each of them have a unique set of suffixes that help identify the pressure range that they're designed for, the characteristics of the accelerometer, and then these are mapped over to an application. So in some cases, the part number is targeted for the valve or rim mount that we spoke about. Others are targeted for the tire mount. And then lastly, there's a couple of part numbers for the cap mount. The other part numbers towards the bottom of the table here are italicized. These are under development. They will be qualified soon. And so at this point, we're able to sample. So customers should feel free to ask it about any of these. And then on special demand, we can actually create other variants as well. So this wraps up our introduction. I would encourage everybody to visit the technology showroom. And if there are any questions that have been entered, we'll be happy to answer them as we go along. And that should settle it for now. Thank you.